Hello everyone, I am Assistant Professor Sonali Bhave. In this part, we will learn linked list part 2, how to traverse the linked list, how to count the number of nodes inside the linked list. Okay. In previous video, we had learned how to create the linked list, what is a linked list, difference between the array and linked list, which operation you can perform on a linked list. Okay. Now, in this, we will see the traversal of a linked list. Traversal means what? Traversal means visit to the each and every node. Okay, start from the first node. Okay, so P equals to head. Okay, P equals to head, address of the first node. Okay, so P equals to head, while P not equals to null till the end. Okay, while P not equals to null, P equals to P is next. Means say assign this head. Okay, head to the P, and then traverse this P to the next, then next, and next. Okay, till the end of array. So while P not equals to null means while this P is this next part is null. Okay, this P is not equals to null. Traverse P equals to P is next. This is your initially P and P is next is this. Okay, now again go to the if this part is not null. Okay, P is not null. Then again traverse to the P is next. Okay, and this is your traversing of a linked list. The next is count function. Count function for what? Here we are using this count function to count number of nodes inside your linked list. Okay. So count from the beginning of the linked list how many nodes are present inside your linked list. So start from the beginning of the linked list. Here int count, we are using the function int count. Int I is one variable. I equals to 0 while k not equals to null. Okay, till the end of array. You see in this linked list how many nodes? 1, 2, 3. Okay, why 3? Because after 3, see, in third node there is a null. It sets to the null. So this is a so see the function int I. Okay, int count int I. Then I equals to 0 means this function will return you integer number how many nodes inside the list. Here is the first, second and third. Null means end of your linked list. Here is a no any node after this because the address field of this node is set to the null. Okay. Int I equals to 0 while P not equals to null. Okay, P not equals to null, I equals to I plus 1. Okay, require the I equals to I plus 1. And then P equals to P is next. Means suppose one node is exists, then increment the value of I is initially 0. P equals to P is next. And complete this after this till what? Till the end of your linked list. And it will return the I, it will return the how many nodes present inside your linked list. Now let's see program to create linked list, print the list and count the number of nodes inside the list. Okay, we will see in this. See, we learned the create function in previous video. Now this is your traversing function and this is count function. Let's see here struct node. Type here struct node int data struct node pointer next. Okay, this is self-referential structure. Struct node pointer next is pointing to again this node. Node pointer create. We are using this function node pointer create. Okay. Void print in bracket node pointer. Then void count node pointer and this here is your main function. This is your function declaration or you can say the prototype declaration of your function. Node pointer head int n comma here we are using the one counter and head equals to initially null. Okay, so printf number of items inside the list, how many items you want inside your list, how many nodes you want, do the here. Then create n, pass this n from here and assign it to the head. Then see here is head. Okay, we are assigning see create n. So write the definition of this function create n first means create a linked list and assign this list to the head. And when you are trying to print the list, then print head. Assign this head here, pass as an argument. Okay, starting of linked list as an argument. And then cnt equals to count head. Okay, so we will count the number of nodes present inside this linked list, and then we will display here. Okay, So let's see, compiler will find out the first the definition of a create and then print, then count. Okay. So here is coding for this create function. So for create function, first node pointer head and pointer p. Then see head equals to node pointer malloc size of node. So first allocate the memory for this head and head next equals to null initially. This is your initial state. And acquire the first acquire the memory, then pointer to the null, and then do the data at the data field. So data field data is suppose 10 or any value. See suppose 20 null. Okay, you suppose you want this element first, then by using create function, see this part. Then head equals to p. Assign this head to the p. See this head equals to p here. Okay, and then we will traverse to the next. Then for I equals to 1, I less than n, I plus this. We want more nodes inside the list till the n node. Okay. So till the n we want the node. So node pointer malloc size of node. So page next. बघा इथं काय करायचंय? Node pointer malloc size of node. इथं काय केलं? Memory allocate केली. But this memory is allocated for this new node. Okay, not for this again. See, this is your first node and after this we want the next node. So this is your next node. Allocate the memory for this. So allocate the memory and this assigns to the p's next. This is your p. This is your initially p. See, this is p and this p's next part is now this new node. So this. Again p equals to p's next. Okay. And then scanf do the data to this. So p's next is what? Now p. Okay. P's next is now p. Means p. Now this is initially this is p and this is next part. Okay. This node's next means this node. So p's next is now p. So now this is your p. Scanf passing the p's data and do the data for this node. Okay. And p's next equals to null. Okay. Means this is your second node. Again for the third node, repeat this for loop. Okay. Repeat this. So I equals to 2. Then assign the allocate the memory. Then assign to the p's next. Then p's next equals to p. Okay. In this way till the end you can process. You need to do this. Okay. After creation, you can print this link. See how to print node pointer p. It means here is your head. Okay. While p not equals to null. Okay. See, while p not equals to null means till the end of your list. See, this p is null. Okay. Till this, you will print the data of each node. We will traverse p equals to p next. Again, we will check if it is null or not. If not, then print the data here. For the count, int I equals to 0, while p not equals to null, till the end of your linked list, I equals to I plus 1, increment the counter, p equals to p is next, go to the next node and return the counter here, return I. So this function will return the first head, and this create function will return your head, then pass this head from the print function and you can print the linked list. Then count, we will pass this head as an argument to this count and it will return to you the counter number of nodes inside the linked list and print the nodes here. After this, how to insert an item inside your linked list. You can insert at the front, middle or at the end. So let's see how to insert the item at the front. Obtain the space for the new node first. Okay, first obtain the space for new node. Then assign data to new node. Okay. So suppose you want to add this node inside this linked list. This is linked list. This present linked list with the first node. This is head and this is your linked list. But I want to add this element here in the new node here. So first acquire the memory for this. Assign the data to this list and this node next. Okay. Assign this node next to the beginning of the linked list and change the reference pointer of the linked list to point to a new node. So means what? See, assign the data. So put x inside the piece data. Then head. Head is here now. Okay. Now head is piece next. Okay. This piece next part is head. And then assign this p equals to head. Now this p is your head. Okay. So insert at the front at the beginning of the linked list. How to insert the data in between? See, here we are using the two pointer p and q. Okay. So suppose you want to add the data in between this and this node. Suppose this is your 1 and this is your next node. Okay, you want to add the 11,200 here in between. So Q's next. Where is Q? This is your Q. See, here is P and here is Q. Before, suppose you want to add the data at the third location. So if you want to add here, then this is your P and this is your Q. Q's next. Where is the Q's next? This is Q and Q's next is equal to P's next. Okay. Now we will convert this. This is your Q. Okay. We will consider this is new node is our P. Okay. Initially. Okay. This is P. So the Q pointing to this location, but now we will break this and now this new P will point to this. Okay. See, जब भी हम यहाँ से यहाँ तक पहले पॉइंटर थे, तो अब क्या कर रहे हैं हम, ये पॉइंटर ब्रेक कर रहे हैं, ये बीच में ये इंसर्ट करने का है, तो ये वाला नोड यहाँ पे पॉइंट कर रहा था ना, तो अभी क्या करेंगे हम कि दिस क्यूज नेक्स्ट पॉइंटर जहाँ पे भी पॉइंट कर रहा था वहां पे कौन पॉइंट करेगा, पीज नेक्स्ट पॉइंट करेगा, ये वाला लिंक वर्क होगा. ओके, तो क्यूज नेक्स्ट इक्वल टू पी. After this, P equals to Q's next. So Q's next is now your P. Inserting at the end. Suppose you want to add the element at the end, then node pointer inserting at the end, node your head and enter. Okay. Node pointer P, pointer Q. First allocate the memory for the insertion P for beginning and for this function in between. We need to write this type of coding only. Okay, but I have given only the logic of this insertion and the beginning. Okay, so you need to write like this: node pointer P, then pointer Q, allocate the memory, then do the data x, do the data as a x, then next is a null. Okay, if head equals to null, then return P, then Q equals to head. Okay, while Q's next not equals to null. Okay, till the end, first traverse your list and then use your P as a Q's next. So add the element at the end of your linked list and return head. Okay, and this coding for you can insert the element at the end, in between, or at any location. Okay, see, this is common code for all the situations, for all the locations. You can insert the element at your given location. So node pointer here, int x and int location. Here we will use node p, q and int I. Okay, first allocate the memory for the new node. See, this is the same for all. Allocate the memory for this new one, then use the data, and next part is next. If your location equals to 1, then use the logic of how to insert the element at the beginning. So assign these heads to the page next and return p. See, q equals to head for I equals to, if location is not 1, then here. Okay, so q equals to head, then for I equals to 1, I less than location minus 1. See, if you want to add the your element at the third location, then stop at the second only. Why? Because we need to do the reference in a second node only for the third node. Okay, so stop one location before the target. So if q not equals to null, then q equals to q next. Okay, if not null, then q equals to q next. Else print overflow. Suppose only 5 elements in your list and you are trying to insert the element at the 6th location, then it is not possible. Okay, so insert the element at the 6th location. So at that time display the message printf overflow. Okay, means suppose the given location this q equals to q next. If q is not equals to null, then only q equals to q next. Okay, else printf overflow and return the head. Okay, then p is next equals to q next. Okay, see, p is next equals to q next means what? At the q next, see, this logic is from this insertion in between. P is next equals to q next and q next equals to p. We will use this same logic from this here. Okay, q next equals to p next and q next equals to p and then return head. Okay. In this way, you can insert the element at the beginning or you can insert the element at the end. Okay, depending on your requirement, you can use the coding, or you can use the same code. Insert the element at the location, given location. Sometimes the question is for insert the element in between, or at the end, or at the beginning. Okay, in beginning. So you can use this code, or you can use the previous separate code for this. Okay, thank you.